Friends, today we will study about the rules of differentiation. So first rule is the function or in power terms. In power terms, if there is a function like y, suppose y is equal to axn, so here a is a constant and n is a variable. So when we differentiate this function, so dy upon with respect to dx, differentiating y with respect to x, so this will be solved as n minus 1. When there is this power function, 1 will be deducted from there and this one n and this n will come downward with the this variable will come here. So in this way we will solve the function with power n minus 1. So it is written in a functional form where a is constant. This is in functional form where a is constant and y is our, here this y is a dependent variable and x is an independent variable. So it is we will read as it change in y because of change in x. Dy upon dx is change in y because of change in x. Now, and here the power of the variable multiplied by constant. This power we will solve ax upon n. This power will be multiplied by the constant a to the power n x to the power n minus 1 and we will deduct 1 from the power. This n is constant only in particular situation because it is variable. So for example, suppose we will take an equation y is equal to 5x to the power 4. So after when we differentiate this function of y, so it will be differentiating y with respect to x, it will be 5 into 4. This power 4 will come with the constant into 4 into x and we will deduct 1 from the power. So this will be 5 into 4 is 20 and we will write x, 4 minus 1 is 3. So this will be the solution. So this is our first function. Now come to the second function. In the rule 2 is differentiation of a constant. Suppose a function is in constant form, y is equal to c. So this is in constant form. So here the x is the power 0. When we differentiate this function, so dy upon dx is equal to c to the power 0 because x has no power and x is 0 minus 1, it will be 0. So if the constant is going to appear independently, there is differentiation is always 0. If constant is going to appear independently, their differentiation is always 0. Now comes to the rule 3. In the rule 3, we will differentiation of a function in the form of addition and subtraction. Form of addition and subtraction. So differentiation of a function in the form of addition and subtraction can be find out by using the rule 1 and rule 2. So do remember the rule 1, that is a function in power term, and second is the differentiation of a constant term. So by using both the rules, rule 1 we use rule 1 and rule 2 here. ठीक है, so we use rule 1 and rule 2. Y is equal to 3x to the power, suppose this is a equation, minus 10x square, 10x to the power 2 minus 3x plus 10. We will differentiate y with respect to x here like this. Dy upon dx is equal to differentiating 3x to the power 4, differentiating x, d 5x cube. Now differentiating 10x to the power 2 with respect to x, minus d 3x with respect to dx, plus differentiating to the power this 10 divided by dx. So we will differentiate y with respect to x here in the equation, and the solution will be, so it will be solved as, we will take the power, we will multiply this power 4 with 3. The power 4 will be multiplied by the constant 3. 4 into 3 is 12 to the power, and 4 minus 1 is to the power 3, plus now second 5 into 3 is, we will see this function, 5 into 5 3 is a 15 to the power x2. 3 minus 1 will be 2, so the power will be 2, minus 10 into 2 is 20, and the power will be 1, so there is no need to write 1. And here the power, we will write differentiating 3x, so we get 3 plus, and differentiating 10, so there is no variable, so it will be 0. So this is our answer. Now comes to the rule 4. Rule 4 is what? Differentiation of a function in the form of a product. We will use D for differentiation of a function in form of product. If the function in question is in the form of the product, if any function in the form of a product, means there is multiplication sign. So when function is in product form, we can find out by differentiating, by getting the product of the terms and differentiating it on the basis of rule 1, 2 and 3, where we use rule 1, rule 2 and rule 3. Rule 1 was the function in power terms, second was differentiation of a constant, and third was the differentiation of a function in the form of addition and subtraction. So in the when we differentiate the function in product form, so we will use all these 3 previous rules. Suppose y is equal to 2x square plus 4x cube, and this is product of 5x cube plus x to the power 4. This is our function, and we will consider, we suppose this term as u and assume this one as v. So our function will be y is equal to uv. So we differentiate the second term. First we differentiate the second term. So the rule is differentiating y with respect to x dy. Second term is this. We differentiate y with respect to x into, so the second term, and now we'll take u Now we will differentiate the first term d with respect to dx into v. So this is our rule of product equation in product form. Now here we take the first term as constant. The first term u is taken as constant, and if the sign is positive you can change, but if the sign is not positive you can't change it. Now we will solve this equation, the above function which we assume this one. So we will solve by using this product rule. Suppose we will consider dy with respect to dx as d 5x cube plus x to the power 4 divided by t to the power x. We will differentiate the second function, that is the v. This is the product rule, and we will take, so this is the, we will differentiate the v. Now what will be the differentiation of u? First differentiate this. 5 into 3. 5 into 3 means 5 into 3 is 15, and we will deduct 3 minus 1 x, it will be 2, plus the power will come near the variable 4x, and we will deduct 1 from the power, so it will be 3. 15x square plus 4x cube. Now the second function du with respect to dx. So what is our du is 2x square plus 4x cube. 4x cube. This is our u function, and we differentiate it with respect to x. Now solve it. 2 into 2 is 4x, and when we deduct 2 from 1 from the 2, it will be 1, so there is no need to write 1, plus 4 will be multiplied by 3. 4 into 3 is 12, and x, we will deduct 1 from the 3, so it will be x to the power 2. So now substitute the above value of dy upon dx and du upon dy, du with respect to dx in the formula of product rule. So when we substitute both the values in this rule, the equation will be easily solved. So now we substitute dy and dx, du with respect to dx in product rule. So we will easily be able to solve it. Now differentiating y with respect to x. So the first is dy with respect to dx. So here is our value 15x square plus 4x. Write this 4x cube. It will be multiplied by the value of u. U is 2x square plus 4x cube. Plus we will add du with respect to dx. So du is 4x plus 12x square. Bracket close, and it will be multiplied with value of y, value of v. So v is 5x cube plus x to the power 4. 5x cube to the power x4. So you can go for earlier or this process, there is no effect on the result. So this is our solution. Now differentiation of a function in the form of a quotient, that is our rule 5. We study about the product rule earlier. We study about addition and subtraction. We study about constant and power. differentiation of power term, constant term, differentiation of a function in addition and subtraction form, differentiation in the form of the product, and now it is about the quotient. Differentiation of a function in form of quotient. Suppose there is a function 2x square plus 4x cube divided by 5x cube plus x to the power 4. So this is our function. Both are divided, they are divided by each other. Now let's assume let's assume 2x square plus 4x cube is equal to u, and 5x cube plus x square x to the power 4, this one as v. So the problem is y is equal to u divided by v. This is our function, will be like this, and we take denominator as a constant always. We take denominator as constant always. So when we differentiate y with respect to x, see how we take denominator as constant. D respect to dx minus divided by v square. So this is our quotient rule. Here we take this denominator as constant, and in this rule we differentiate first u and take the v as constant. So we take denominator as constant always, and dy we differentiate y with respect to x by substituting the value in the quotient rule. We will get the results. As we assume u and v, now we will substitute the differentiation of u and differentiation of v in the quotient rule, and we will get the values. So first differentiate u. What is our u value is 2x square plus 4x3. 2x square, differentiating u with respect to x. So this is our first take the u. What is u? What is our u? So our u is 2x square plus 4x cube, and v is 5x cube plus x to the power 4. Now when we differentiate u with respect to x, we get 4x plus 12x to the power 2, and when we differentiate v, we get with respect to x, we get 15x square plus 4x to the power 3. Substituting value in equation 1. Now we will substitute both the values of this and this in equation 1, this in quotient rule. So let's substituting value of dx and du with respect to dx in quotient rule. So it will be, first see the value of y. dy with respect to dx equal to v into du with respect to x. It's plus, it's minus sign. dv with respect to dx divided by v square. So substitute the value here. Du with respect to dx is du with respect to dx first we will write the value of v. What is the value of v? Is 5x cube plus x to the power 4. X to the power 4. Multiply this by 4x plus 12x square minus, and u is 2x square plus 4x cube. We will write the value of u. Two x square plus 4x cube, bracket will be closed. And what is the value of dv and dx? 15x square plus 4x. So it will be 15x square plus 4x cube divided by v square. So v is 5x cube plus x to the power 4, and square is this, v square. So this is how we will solve the function in the form of quotient. Now let's come to the rule 6. Rule 6, differentiation of a function and of a function is a chain rule. We call it as chain rule. If a problem in question is given in the form of a function, or is a function of a function, or we can say it is a composite function in which y is a function of u, and u is a function of x, and u is a function of x. So find out differentiating y with respect to x. When we find out dy with respect to dx, in such cases we recommend y is equal to f to the power u, and y is equal to, sorry, it's not y, it's u with respect to x. So this will be like y is equal to f to the power g into x, bracket close. So this will be the change in x, change in y because of change in x, change in y because of change in x, and u is independent variable. Here u is independent variable, and the derivative of y with respect to its equal, derivative of y with respect to its equal to the derivative of first function, to the derivative of first function with respect to u, and the times the derivative of first time, which is dy with respect to dx, is equal to dy with respect to du into, it will be with respect to dx. So this is why we call it as a function of a function. This is our chain rule. This is a chain rule. So here, if y is our y is u divided by 5 and u is x divided by 3. So we will solve this as differentiating. We will substitute the value in this, in the above chain rule, and what will be the dy upon du is dy, when we differentiate y with respect to u, it will be 1 upon 5, because there is no value of no power of u, so it will be 1 divided by 5, and when we differentiate u with respect to x, we will get 1 divided by 3, as x has no power, so it will be 1 divided by 3. Now we will substitute the values of this and this in the chain rule, like this. Differentiating y with respect to x, it will be 1 dy upon du. What is dy upon du? Is 1 upon 5 into du with respect to dx is 1 divided 1 into 3, so it will be 1 divided by 15. The next as the next problem, so another problem, for example a function, another function we will take. Suppose y is equal to 2 to the power x2 plus 3 to the power x cube to the power 4. Whole function is to the power 4. Y is, we assume y as, we assume this function as u. So y to the power u is to the power 4. So it will be, when we differentiate this, it will be 4u to the power 4 minus 1 is 3. Now when we differentiate y, when we differentiate the function above this function, when we differentiate this function, so dy with respect to dx, it will be, the power comes near the variable as 4 and 2x square plus 3x cube, and 4 minus 1 is 3, and we will write the u, we will write the differentiation of u with respect to x as 4x plus 9x square. This is another solution. So this is another solution. Now let's come to this function of chain rule has two yes, this function of chain rule has two different sub functions, we can say two sub functions. First is differentiation of power on expression in bracket. Suppose y is equal to 3 plus 2x square to the power cube. Assume 3 plus 2x square is equal to u. So we write y is equal to u to the power cube. Therefore, differentiating u with respect to x is equal to 4x, and differentiating y with respect to du is 3u to the power 2. But the chain rule is dy upon dx is equal to dy upon du into du upon dx. This is our chain rule. Okay. So we will substitute the value here. We will substitute our values. Du with respect to dx is 4x, and dy with respect to du is 3u square. So this is our function of dy with respect to dx. Now when we substitute the values of u and x, so we get, since u is 3 plus 2x square, which we assume. So now we substitute the value of u in this equation. We can say in equation 1, substituting u in equation 1. So here differentiating y with respect to x is equal to 3 to the power 3 2x square to the power 2 into 4x. So it will be, when we substitute the u value in this equation, in equation 1, so we get 3. So 4 into 3, we multiply 4 into 3, it will be 12x plus 3 plus 2x square to the power whole square. This will be our solution of our differentiation of a power on expressions in bracket. Now the second rule of this chain rule is sub rule of this chain rule is differentiation of roots of expressions. The above chain rule is also useful when the relationship involves roots such as so this suppose there is a function and we will differentiate it. Let's assume 8x cube plus 5x as u. We assume this as u, and so our function will be y is equal to 1 upon under root u. It will be written as u to the power minus 1 upon 2. So when we take something as a denominator as numerator, so it will be like this, and we remove the root. So negative sign because it became a numerator, so it is negative, and 1 by 2 because we remove the root, so it will, the power has 1 by 2. Now differentiating y with respect to u, we will differentiate this function with respect to u. So it will be, we substitute the value of u. Actually we are substituting y is equal to u minus 1 upon 2. We are derivating this function, so we are derivating this. So minus 1 upon 2 to the power u to the power 3 minus 2. Why it is 3 minus 2? Because when we deduct minus 1 upon 2, and when we deduct 1 from this, so it will be like 2 minus 1 minus 2 1 is 2, so it will be minus 3 divided by 2. So it will be minus 3 divided by 2. So this power will come by when we deduct minus 1 upon 2 1 from this, and we get minus 3 upon 2, and this 1 upon 2 will come with a variable u. So solving this, So our difference, after differentiating y with respect to u, we get minus 1 upon 2 u to the power minus 3 upon 2, and differentiating u with respect to dx, we get y, as we assume u as because of we consider u as 8 to the power 3 plus 5x. So this 8, when we differentiate this value, so we get 8 into 3 is 24. 24x to the power 2, we are differentiating this, plus 5, not x, because x has no power. So we get the value. Now we will substitute this value and this value in our chain rule. What is chain rule? Chain rule is dy with respect to dx is equal to dy upon du into du upon dx. This is our chain rule. We substitute both the values here. So we get minus 1 upon 2 u minus 3 to the power 2 into du upon dx is 24 x square plus 5. Here minus 1 upon 2 is 8x cube plus 5x minus 3 upon 2 into 24x square plus 5. So it will be minus 24x square plus 5. Here this will come as here as a denominator, and this term will come as denominator because there is a minus sign, so we can take it as a denominator. So it will be, and this minus 1 is also removed because we take it as a denominator. So 8 to the power x3 plus 5x to the power 3 by 2. Are you getting my point? Because we can see there the minus 1 upon 2. So we take it as a denominator. The whole term, this term, we take this term as denominator because there is a minus here and there is minus here. So we take it as a denominator here, and so this will shift here. Actually, sorry, this minus term will remain here with this 24 by 5. Minus term will remain here, only 1 upon 2, so it will remain as 1 upon 2. Minus 1 upon 2 will remain as it is, but minus 3 upon 2, because of this minus 3 upon 2, we take 8x cube plus 5x as our denominator. So our value will be minus 24x square plus 5 divided by 2. As there is a 1 by 2, so we can take it as an under root 8x cube plus 5x to the whole power 3. We didn't write 2 because we take it as a root. So this is our answer. Now take the second problem. One more problem. Consider a function like this. Consider a function, suppose y is equal to 2x square plus 3x cube to the power 4. Let's assume 2x square plus 3x cube is equal to u. So y will be u to the power 4 because we consider this as u. Now solve. We were differentiating y with respect to u. Differentiating y with respect to u, so it will be 4u to the power cube, and we will differentiate y with respect to x, it will be 4u to the cube to the power 4x plus 9x square. Now substituting value here in equation, we differentiate y with respect to x. We will substitute the value of du upon dx and dy upon du. We will substitute the value of u here. So what is our u? U is 2x square plus 3x cube to the power cube, 3x cube to the power cube, and 4x, it will be written as it is, 4x plus 9x square. So this is our solution of differentiating y with respect to x. And solving directly, we can, there is another solution also. We can solve with another way. Another way is the same question we can take 2x square plus 3x cube to the power 4. So when we differentiate dy with respect to dx, we get 4. The power will come here with the variable 2x square plus 3x cube, and the power, its power will 4 minus 1 is 3, and the same the means the derivation of u with, so 2 to the 4, 2 into 2 is 4 to the power x plus 3 into 3 is 9 to the power x2. It will be written nearby as a product. So this is our solution. We can solve, both the answers are same. You can see this and this, the solutions are same. We can solve directly or using the chain rule also. Now the powers of expression and the roots of expression, these involve the substitution. Both the powers, the roots of expression and the powers of expression, these two needs the substitution in the chain rule, and in the implicit function these cases require derivation of differentiation of each term in implicit function. So function of a function, I think you will get it. So our chain rule, this is a function of a function. Now comes to the rule 7. Let's comes to rule 7. If function relationship between two variables is represented in the form of explicit we will take here as an implicit function. In the form of implicit function, between, there is implicit function means functional relationship between two variables. For example, suppose x square y plus y minus 2x cube is equal to 0. So the derivation can be found out, the differentiation of this can be found out by differentiating each and every term with respect to x. We will differentiate each and every term with respect to x. Let's write it. Differentiation can be found out by differentiating each and every term with respect to x. So x square is constant. Here the x is constant, and we differentiate y in above equation, which we take this. So we take x square, differentiating y with respect to x. X is constant, but now we differentiate this y as y, differentiating dx square because we take it as a constant dx, and here differentiating y, this y function you can see with respect to dx minus d, we differentiate this 2x cube, differentiating dx is equal to 0. So what we do here, we do differentiating, when we differentiate x square y, we differentiate x square y, so we do it like this: x square as a constant, differentiating y with respect to dx, plus there is product when there is a multiplication, so we add plus and differentiate y with respect to d square dx, as d square is constant. So this, through this we differentiate this term, we are talking about x square and y. So here now let's forward x square differentiating y with respect to dx plus y into 2x, we get 2x because it has two powers, so take a small y. This has a power where, so it will come near the variable 2x plus dy by dx will remain as it is, minus 6x square. It will be like to the power 3, so it will be minus 3 to the power will with this is to the power 3, so 3 into 2 is 6x, and 3 minus 1 is 2, equal to 0. X square dy with respect to dx plus dy dx equal to 6x square minus 2xy. So this xy we take on the right hand side of the equation, we take 6x square, and this both the terms we take on the right hand side and take dy with respect to dx as a common, x square plus 1. We take these terms common and x square plus 1 will be left here, and here it is x square minus 2xy, which will be written as dy with respect to dx is equal to 6x square minus 2xy upon x square plus 1. This is our solution. If we want to see the change in x with respect to y, if you want to see the change in x with respect to y, so dx upon dy and dx square upon dy, it will be wrong. This is not correct. We can't, it is not possible to differentiate with respect to, it is not possible to differentiate with respect to y. It is not necessary that each function can be differentiated. So each function cannot be differentiated. We can't do it if it is in square form. We can't do it if it is in square form. So each function can't be differentiated. This is all. So here we have all these 7 rules. You can go through. First is the function in power term. Second is differentiation of a constant. Third is differentiation of a function in the form of addition and subtraction. So this is the rule of first equation in a power term. This is a rule of second equation when there is constant, and rule in addition and subtraction. So in addition subtraction we can see how to solve, and in the function, fourth is in the form of product, so we use 1 2 and 3 rule, and so we use this rule. We differentiate the second function first and then take first as constant, and in the fifth rule we differentiate the quotient in the, when there is a quotient, when there is division, this rule. So we follow this rule, quotient rule, And sixth function, when differentiation of a function, there is a chain rule. So we take this as the chain rule as a function to solve any function of a function or a chain rule, and there we can solve it directly also. There it has two sub functions, in when there is a power and when there is a root. In both these we use the same chain rule when there is a root. So the same chain rule will be used in both the functions. Now the seventh function is an implicit function between the two variables, so we can differentiate it by using the another formula. We differentiate each and every term with respect to x. This is how we solve it. If there is any problem, you can ask in comment. Thank you so much.